Hello and welcome to Operations Management videos at edupediaworld.com, your favorite portal for online education. We are dealing with facility location, and today we shall take up some of the methods of determining the most suitable facility location. To begin with, let's take the dimensional analysis. So this session we'll see what basically dimensional analysis is, how it works, and at the end we'll take a few problems to consolidate our understanding. Here we go. Dimensional analysis is one of the methods of making an integrated comparison of alternative sites on the basis of both the tangible and the intangible cost. While selecting a plant location, we would like to optimize different objectives which could be interrelated but cannot be represented in the same dimensions. The location decisions can be taken by making use of dimensional analysis. In case if you have a location where you have different factors to compare, some of which are represented in terms of the amount of money spent, like for example the cost of the land, the cost of procurement of raw material, and so on, and some others which could be in terms of which could be rated on a scale, maybe from 1 to 10, like for example the healthcare facilities, the recreation facilities, and so on. So when you have both of these kind of factors to be compared, of course we would like to optimize all of these at the same time. So in these cases we use dimensional analysis. Well, this method is also called as the Bridgman's dimensional analysis, as it was developed by Bridgman in the year 1963. If all the costs were tangible and quantifiable, the comparison and selection of a site would be easy. The location with the least cost is selected, and their relative merits and demerits can also be compared easily. But in most of the cases, intangible costs are present, and these costs are expressed in relative terms than in absolute terms. Since both tangible and intangible costs needs to be considered for a selection of a site, we are using the method of dimensional analysis. This method is used in computing the relative merits, that is the cost ratio, for each of the cost items for two alternative sites. So here at a time we can compare only two sites. In case if we have more than two sites, what we do is we first take any two, compare both of them, pick the better one, compare that with the next one, and so on. For each of the ratios, an appropriate weightage by means of power is given, and multiplying these weighted ratios to come up with a comprehensive figure on the relative merit of two alternative sites. Well, what we do here is we take the ratios of both the sites selected, we take each factor one by one, we take the ratio of the value of the first factor of both the sites, and we raise it to a certain weight. The weight actually is taken as per the importance of that factor, okay, and the weight is put in the power, and then all of these factors are multiplied, and finally we come up with a comprehensive figure which gives us the value of the dimension analysis for these two factors, and this is given in terms of the ratio, in terms of the cost ratio. Let's take by way of an example and let's understand. Let's say we have two different sites, M and N, and these two sites are to be compared, and their various cost components could be given as, say for the first one, that is for the site M, it could be as C1M, C2M up to CNM. C stands for the cost, 1 stands for the first factor or the first component, first cost component, and M is for the site M. So we have C1M, which means the cost of the first component of site M. Similarly, we have cost of the second component of site M, cost of the nth component of site M. Okay. Likewise, we also have the cost of all the components 1, 2 up to n for site N here, represented as C1N, C2N, so on up to Cnn. Okay, now weights of each components could be given as W1, W2, so on up to Wn. Now if you once you have all these data with you, the dimensional analysis value, which we could call as DAV, is given by the ratio of the first component raised to the power of the weights multiplied by the ratio of the second component of both the sides m and n raised to the power of the weights W2, and so on up to the last one, that is the ratio of the nth cost component of both the sides m and n raised to the weight of the nth component. Okay, so here we have the formula to calculate the dimensional analysis value. It's C1m by C1n raised to power W1 multiplied by C2m by C2n raised to power W2, so on up to Cnm Cnn raised to power Wn. Once we have got the values, we'll have to see whether the value is less than 1 or greater than 1. In case if it is greater than 1, then site n is superior, that is the one in the denominator. So keep this in mind. In case if the value of the dimensional analysis DAV, which you have calculated, is greater than 1, then the side which is represented in the denominator will be superior, and if it is less than 1, then the side which is represented in the numerator would be a better choice. Now in case if you take the profit into consideration instead of the cost, then the condition would reverse. This is not the usual case and doesn't happen, but just a point to note. Alright, so this is what we have in dimensional analysis, and I think it's simple for you to understand. If so, yeah, let's move on and let's take a few numerical problem. Well, so here we have a very simple problem, the first one, where we have the data of two locations m and n given here to us. Okay, we have the site m and site n, and the cost values for different factors are given. The cost of labor is given as 20,000 for site m, and the cost of labor for site n is given as, sorry, it's 200,000, and here it's 100,000. Similarly for power, it's 4 million, and here it's 2.5 million. Okay, then we have the educational facilities, and this site m, the rating is 2, and for site n it is 6. For healthcare facilities, site m it's 2, and site n it is 4. And when we compare the weights of the first factor is 1, the second factor is also 1, the third factor is 2. That is, now this signifies that this factor is of double importance than this or this factor. Okay, similarly healthcare facilities, again the weights here is 2. So let's do this, let's compare, let's find the ratio of site m by site n. So we have site m by site n. Okay, and the values would be, for the first one it's going to be 200,000 divided by, sorry, it's 100,000 raised to power 1, and that would be multiplied by 4 million divided by 2.5 million, again raised to power 1, and that would be multiplied by 2 over 6 raised to power 2 this times, and then 2 over 4 raised to power 2. Okay, now this is simple to solve if you just take the ratios. Let's do this on an Excel sheet, or let's simplify it first. So when we simplify the values here, we will have this as 2 by 1 raised to power 1, which is nothing but 2, and here this would be equal to 40 divided by 25, which could further be written as 8 by 5. Let me write it as 40 by 25 raised to power 1, and then this would be 1 by 3 raised to power 2, and this would be 1 by 2 raised to power 2. Let's solve this on an Excel sheet. Of course it's simple, it's trivial to do it here itself, but let's understand if we can, how can we do it on an Excel sheet. It's very simple. You can just put it in the formula here. You have the cost of the labor of both the sites M and N here. That could be written as the value here divided by the value below this for N, and that would be raised to the weights given here. Okay, so that's what, and again we had the same value here, it's 2. Next would be, again I can just drag this because I'm going to use the same formula for all these cells. Therefore when I drag these up to the last one, I get the values here. Fine, and that's what we have here. 40 by 25 would be 8 by 5, and 8 by 5 is nothing but 1.6. Here we have 1 by 3 raised to power 2, and here we have half raised to power 2. Now the product of all of these, let's calculate the product of the values from the first till the last would be 0.08. And if we have to solve it manually, you can always go and solve it, as the calculations are simple in this case. So first one is 2, that is multiplied by 1.6, and that is multiplied by 0.111, and lastly it's 0.25. And when we calculate this, the product of these four, it's going to be 0.088. And obviously this is less than 1. Since the value is less than 1, we would select M. Okay, that's the one in the numerator. So site M is selected or select site M. Okay, so here we have site M as more meritorious in comparison to site N. Well, let's take another problem, and this time you'll be solving it yourself. We have the question here. Again, you are asked to select the most appropriate site using the Bridgman's dimensional analysis. You have totally 4 different factors, or in fact totally 6 different factors this time, for 2 different sites, site 1 and site 2. So calculate the values and select which of the two, site 1 or site 2, is better. Pause me for a while, solve it, and then we'll do it together. Well, so let's do this together. I hope this is simple and you must have solved it by now. So here we have site 1 and site 2. So let's take the ratio of site 1 and site 2. 1 over 2. Fine. So the first factor, which is the building cost and equipment cost, here is 2.5 million for site 1. So it's 2,500,000 divided by, for site 2 it's 1.5, and this has a weight of 4. This is to be multiplied by the second factor, which is 25,000 divided by 100,000, and that's again raised to power 4. Further, this is multiplied by the next factor, which is 100,000 divided by 150,000, and this is the power cost per year. Again, this also has a high weight of 4. This is multiplied by the next. Now you see that the first 3 are given in terms of the cost, whereas the next 3 are in scales. Okay, so next, community attitude is 2 over 4, and this has a weight of just 1. Next is 4 over 6 with a weight of 5, and finally we have 5 over 30 with a weight 2. So again, when we calculate this, when we cancel out these 2, in the first case we will have these zeros will go away, and then we'll have 25 by 15, which we can cancel out as 5 over 3 raised to power 4. Okay, further this one would be 25,000 and 100,000. It will simply be 1 over 4 again raised to power 4 multiplied by 100,000 by 150,000, it's simply 2 by 3. We can simplify them easily as the values are not in prime numbers or odd ones, they are even, and you can cancel out and solve them straight away here. Or maybe you can use the Excel sheet which we did for the previous one. Okay, the next one would be 2 by 4, which is simply 1 by 2. This time it's raised just to power 1. 4 by 6 could be written as 2 by 3 raised to power 5. And finally we have 1 over 6. 5 by 30 is 1 by 6 raised to power 2. And of course you can make use of the Excel sheet to solve this. I'm directly writing the answer for this one. The answer, when you calculate the values here, would be equal to 0. It's going to be a small number, 0.00008. Sorry, 108. 108. So it's, you can say it is 1.08 into 10 to the power minus 5. Okay, now this is a very small number, much below 1. Okay, and so when it is less than 1, what we do, we select the one which is in the numerator. So this was in the numerator and this was in the denominator. Therefore now, since the numerator since the value is less than 1, we select site 1. So here again select site 1. Alright, so this is a better choice in comparison to the second site. Alright, so that's our second question for today. And finally, let's take a question where we have 3 sites. Okay, so here we have an equipment supplier has collected the following data on the possible plant locations. You have the factors given. This time again you have 6 different factors, 4 of which are in cost and the remaining 2 are in terms of the ratings. And this time we have 3 different sites. We have site P, Q and R. Okay, if you were responsible for making the decision on the basis of the information given above, which site would you select and why? Use dimensional analysis. So again, this is simple and we can make use of the Excel sheet to solve them very quickly, or we can solve them here itself, as the problem is not very complicated, and further it will help us in consolidating our understanding and help us in calculating manually. Yeah. Alright, so first let's take the 2 sides P and Q. Let's take the ratio of P over Q. When we take the ratio of P over Q, the first one, it will be 20,000 divided by 24,000, and this time you see that the weights are not given. So in case if weights are not given, we will assume that all the factors are of equal importance, therefore the weights of all of these would be 1. Okay, so let me write that here. Weights or importance of all of these are going to be same, 1, and 1, when we have the weights as 1, the power as 1, it doesn't make any difference whether we apply or we don't apply. So we'll just take the values as it is and find the ratio. The first case, when we have the first one, rent and utilities, for P and Q, it will be 20,000 divided by 24,000. The second would be 4,000 divided by 3,000. Let me write that straight away as 4 by 3. Third would be 190,000 divided by 160,000. Okay, so that will be written as, say, 19 over 16. The next will be 260,000 divided by 264. Let me write it as 260 by 264. Last is 2 by 4. Sorry, the second last, and finally last one is 3 by 3, which is 1. So when we calculate all of these, of course here you can cancel out these zeros, it's 20 by 24, and all of these are raised to power 1. So again, this is a very simple calculation. You can either use the Excel sheet as we did in our first problem, or you can use the calculator and find the values. So in the first case, when you calculate this, I'm just giving you the answer. The value would be 0.649. Now since this is less than 1, okay, what we do, we select the one which is in the numerator. Okay, so select P. So now out of P and Q, we see that the site P is a better option. Okay, next if we compare these two, so first comparison we saw between site P and Q, we saw that P is a better option. Okay, now let's compare site Q and R. So when we compare Q and R, we'll take again the ratio of Q divided by R, and this time when we take Q by R, it will be 24 by 30. The first factor will be 24 by 30 multiplied by the next one would be 3 by 2, because it's 3000 by 2000, so it will be simply 3 by 2, and that will be multiplied further by 160 or 16 by 18. 16 by 18. Yeah, the next one would be 264 divided by 254. 264 divided by 254, and then we have 4 by 3, and finally it's 3 by 2. 3 by 2. And when we calculate the product of all of these 6 ratios, the value which we get is 2.2173, and this time it's greater than 1. Since it's greater than 1, we select the denominator, right? Select the denominator, and we know that the denominator in our case is R. Therefore R is a better option this time. Select R. Okay, so this time we are selecting R as the better option. Last time we had selected P. Now we are left out with the comparison of P and R. So let's take them here. P divided by R, the ratio of P by R, when we take the first factor would be 20 by 30, which is 2 by 3 straight away. 2 by 3. The next would be 4 by 2. 4 by 2. Third would be 19 by 18. 19 by 18. Fourth would be 26 or 260 by 254. 260 by 254. The fifth would be 2 by 3. And the last one would be 3 by 2. And when we calculate, let me write the solution, the answer of this, P by R over here. When you calculate the values here of all of these, you see that the last two, I mean the calculation is really very simple. You don't have to struggle much here. You can cancel out the several values, like for example you can cancel out these 2's here, you can cancel out the last 2 completely, and you'll be left out just with a few numbers which you can easily calculate using either your calculator or of course if you go to the Excel sheet, it's very simple and you can do it yourself. Anyway, let me just give you the answer. So when you find the value of, when you calculate the value of P over R, the ratio of the last values here, it is in fact more than 1. Okay, so it's going to be 1.4406. okay, greater than 1. When it is greater than 1, what we do, we select the denominator. So select the denominator, and in our case here the denominator is R. Okay, so now again we select R. Okay, so let me summarize the data here for all the 3. First we took the ratio of P by Q, and the value which we got for P by Q is 0.649, which was less than 1. Therefore we selected P. Okay, that is P is better than Q. Next one, when we took the ratio of Q over R, the value which we got was 2.2173, which is greater than 1, and this time, since it is greater than 1, we would select the denominator. So select R, that is, we say R is better than Q. Now we see that both P and R are better than Q. So now finally we are left out with the comparison of P and R. So when we took the ratio of P and R, the value which we got was 1.4406, which again is greater than 1. Therefore we would select again the denominator, which is the value R, the site R. Okay, so finally again we selected R. So we now again say that R is better than P, and therefore we can say that R is the best choice or the best site, okay, followed by P. Why? Because P is better than Q. And then finally we have the last choices. The last choice is Q. Okay, so that's the solution of the last problem. Well, so that's all we have in this session of dimensional analysis, and let me just summarize that when we use dimensional analysis, we can select any two sites at a time. We can compare their values, and it can compare both the tangible and the intangible cost, that is, the objective and the subjective factors comprehensively, and it gives the decision maker one integrated quantity, okay, one integrated quantitative figure, and this obviates the necessity of making two separate comparison, one for objective and another for subjective, and then coming up with you say necessarily a qualitative or a subjective decision. Okay, that's one thing, but again we can only compare two at a time. If we have more than two, we'll have to do as we did in the last question here. Now, by taking dimensionless ratios for each factor, it can incorporate the actual cost for the objective factors, and at the same time use subjective scores of the cost for the factors for which cost cannot be determined. And further, the relative merits and demerits of the site can also be compared easily using this method. Well, in the upcoming sessions, we'll take up other methods of facility location. Keep watching Edupedia World videos. Thank you.